Hi, so today we are going to look at some of the problems from chapter 13, which is based on sampling distribution. So here's a question on glucose testing. Please pause to read through the question and then we are going to go over the subtypes. So after you finish this question, you first thing you always derive what has been asked and see what kind of problem they are asking you. There are two types of problem. When x is given and you're supposed to find the area or percentile or proportion or probability, one and the same thing. Or the other kind of problem is the reverse way, that the area is given and x has been asked to calculate. So if you read through this question, the first part A, they're asking to calculate the probability. That means we have to go this way. So just follow the steps so that the complex problems will become easier for you, but you can skip it or combine for simpler problems. First step, it's always good idea to draw the curve and see what has been asked. So in this question, subtype A, they are asking glucose level more than 140 is when we call it as a gestational diabetes, and we have to find that particular probability that that person, Sheila, is diagnosed with gestational diabetes. So if we draw the kind of normal distribution curve with mean of population is 125. Remember, this is X distribution and not the Z because it's still the original values. And we can locate this X 140, and we are interested in Sheila being diagnosed as gestational diabetes, and gestational is when glucose is more than or above 140. So that is the particular area of interest or the probability of interest that we have been asked. Once you know the question, go back to the question and see what all other information is given to you. So it is normally distributed with mu 125 and sigma or population standard deviation as 10. So you can write it in this standard format or the commonly used notation: normal distribution 125, 10, mu, sigma, and that's separated by comma. X is 140 because that's something that value that we are interested in. So we have completed the first and second step here. Now, once we know these steps or the kind of problem, it's just pure math to solve and get the z value and then use table to get the probability. So for z, we need x, mu, sigma, and we know from the given data we have both all these three values. So we can calculate z and we can get it as 1.5. Once you know the z, remember z would be representing this x value, but we are interested in the area on the right side of the z that is greater than or above 140. When we use table from outside to inside, the z-score gives us, from table, gives us area always left to that z. Okay, so z table always gives us this dark green color area, not the other on the above side. Okay, so if we want the above, the area above, we know the total area is like the total probability, so that represents 1, and we can calculate the probability which is left to this z using the table directly, right? And we should be able to get that as 0.9932. Now let's see how we got that 0.9932 using z value 1.5 and table outside inside. So just look at the z value, see positive 1.5, these are negatives. Sign is very important, and you can locate positive 1.5 and the corresponding value because we are only looking at 1.5 and there's no further second decimal. So that's 0.9332. So that is how we got that value as 0.9932. Once you subtract, you are going to get the desired p-value because total area is 1 and we are subtracting the area for z, and the table z gives us area left to that particular z, right? So that's white, but we are interested in this red area, everything above 140 blood glucose. That's why we are subtracting that particular z left from 1. That's how we get probability of z being greater than 1.5, or you can also say x being more than 140, or in other words, probability that Sheila is diagnosed having diabetes, gestational diabetes, would be 0.0063. Now let's look at the B part. B part is saying if measurement are made on 4 separate days. Okay, so that is something different than the previous question we had. 4 separate days. The mean results is compared with the criterion of 140, so that remains same, 140. What is the probability that Sheila is diagnosed having gestational diabetes? So it is a similar kind of problem because it's based on same question that we are looking at the same probability, right? So we are calculating the same probability. And that's similar kind of problem. Probability has been asked, x is given, mu given, sigma given, x is we know. So we can follow the same steps over there. So first step is always draw the graph. So in here the graph will be same, and you can see that this is roughly normal distribution with mu given value. So you can just repeat this procedure here. Step 1, mu 125 and 140. What is different here is the sample n, because we measure, if we measure the measurements are made on 4 separate days, that means our sample in here are 4. Okay, so that is something different. But for step 1 and 2, just refer to previous steps from the question, but this is the only unique that we have for this subtype question B. So what we are going to do when we calculate the next step z is we are going to use formula x minus mu upon sigma divided by n, that is the sample size. So from theory lecture you will know why we divide that by n, but for this lab I'm going to skip that theory part. So once you know this formula, you just substitute and it's pure math. So x is again 140, mu is 125, sigma is again 10 by 2, that's given in question stem. And what is different is the n here, which is given only for subtype B. Okay, and it's actually the square root of n. I apologize for that formula. So once you know that, you just solve this. This is going to be 15 over 10 divided by 2. That's nothing but 15 over 5. That's z value of 3. Okay. So last step is calculating the probability. Again, the same thing. We are going to look at the z value, and we are interested in area right side of that particular z, but the table always gives us area left side of the z. So if we look at the z of 3, it's going to give us area left to that. So let's look at for z and the corresponding probability using the table outside in. So positive 3, we can see we can locate 0.9987. So Z for that corresponding area is 0.9987. I'm just going to write here roughly. But our area of interest is the probability being x being greater than 140, or in other words, Z being more than 3. Okay, so that part remains same. We know the total probability is 1 because it's considering all the area under entire curve, minus that green area, that is area left to the z value or x value corresponding that we got from z table. And once you do that math, you should get the final answer, 0.0013. Alright, so that's it. And if you like, you can also write down the answer in the word form as a final answer, that the probability that the Sheila is diagnosed having gestational diabetes would be 0.0013 in this case, given that there were 4 separate measurements made.